The most challenging aspect of long-range shooting is understanding the effects of wind on the path of the bullet. The effect of the wind has on the path of a bullet depends on the velocity of the wind and the direction in which it blows. The velocity of the bullet is relative to the air in which it travels. For example, in a tailwind, the velocity of the bullet is slightly less relative to the moving air than it would be in still air. Less velocity means less drag and the bullet hits a little high. Just the opposite happens in a headwind. The velocity of the bullet relative to the moving air is slightly higher. More velocity means more drag and the bullet hits a little low. Headwinds and tailwinds of lower velocities and at short ranges do not produce much of a difference in bullet drop. They can have an important influence at longer ranges and if the wind is strong. Headwind has slightly more of an effect than tailwind. Crosswind has a strong effect on the horizontal path of the bullet. Crosswinds that are exactly at right angles to the shooter's line of sight are called full value winds. Winds at 60 degrees from the right angle are called half value winds. Half value winds also have components of head and tail winds. A gust of wind close to the muzzle will have more of an effect on the bullet path than further down range. A cross velocity imparted early will be retained throughout the rest of the time the bullet is in motion. Newton's first law of motion. A gust downrange near the target will have little effect on the point of impact. When shooting in canyons or mountainous terrain, there can be vertical wind effects which lift the bullet. On target ranges, wind flags help determine the wind conditions. In the field, other objects such as trees and dust are observed to establish the velocity and direction of the wind. There are also reliable wind meters which give the value of the wind at the shooting position. One way to determine the direction and velocity of the wind is by observing the angle of heat waves, the mirage, seen through the scope. Heat waves are caused when hot air near the ground mixes with cooler air above. The bending of light as it passes through the different densities of air causes the mirage effect. The target will appear displaced for the same reason. The heat waves will bend in the direction that the wind is blowing. In lower velocity winds, the waves will be oblique to the vertical line. At around 12 miles per hour, the heat waves are horizontal. Duplicating the mirage effect in these simulations is difficult, so it will not be discussed in further detail. If a wind is coming from the left, 9 o'clock, the bullet will be displaced to the right of the target if no adjustment to the windage knob is made. Measured in inches, this is called wind drift. To hit the target, the bullet impact needs to be moved to the left. The windage knob on the scope is rotated to move the impact left. View the top of the scope knob by placing the mouse cursor over the knob. In the simulation, the windage is set by using the left or right arrow keys. The impact is moved to the left using the left arrow key, and to the right using the right arrow key. Your range card gives the wind drift in inches for a constant 1 mile per hour full value wind. The drift is stated in inches to determine a more precise final value than if the drift was in minutes. Once you have determined the velocity and direction of the wind, convert inches to minute of angle to get a windage setting. Example: suppose you have a 10 mile per hour full value wind at 630 yards. That's 3.2 inches times 10 equals 32 inches. Divide 32 inches by 6.3 inches to get 5.08 minutes. Adjust your windage dial 5 minutes in the correct direction and you should hit the target. There can be different wind conditions all down the range affecting the path of the bullet. The only way to really understand the wind is to spend time shooting in it.